Okay, so I don't bother with the magnitude. I don't want to bother getting a unit normal. I'm just going to get any normal to the graph, so I do this cross product. J cross I is negative k. J cross k is I. So J cross 1/3 k is 1/3 I. Negative 2/9, well, negative k cross I, use your right hand rule, and this is where I better be careful. Negative k cross I is negative j. And boy, I think I screwed something up there. Let's see. K cross I is j, so negative k cross I would be negative k cross I. It gives me negative j. And I've got a negative 2/9 here, so I messed up. That should be positive. Remember to always check yourself like I don't. Okay? And then negative 2/9 k cross k is just going to give you 0. Let's see, my 2/9 j should have been positive here as well. So we only have these three components, and I put them now in the order I, j, k. And hopefully I've got the right signs on everything. Now, the point is 2, 3, 2/3. What's the condition for the tangent plane? Okay. A vector from a point out to x, y, z. Okay, from the point 2, 3, 2/3 to x, y, z is x minus 2 times I, because in the x direction you're going from 2 out to x. Okay, that displacement is x minus 2. Similarly in y, to go from the point where y equals 3 to the point where you have just y coordinate y, you got to move y minus 3. So it's y minus 3j, and then similarly z minus 2/3 k. You got to dot that with the normal vector. Okay, well, correcting my sign on the j, I should have a plus here. You dot that with the normal vector. Why? Because a vector in the plane has to be perpendicular to the normal vector. That's what normal means. That's the only condition. The point x, y, z will lie in this plane if the vector from this point out to x, y, z, which is this vector, is perpendicular to the normal vector, meaning that its dot product with the normal vector is 0. This is how you really want to understand the equation of a plane, not a formula that you use. Go ahead and use the formula, but every time you do, think about where the formula comes from. It's not difficult. Okay? And pretty soon you have this picture, and you don't need to remember a formula that looks a lot like other formulas. You have a picture, and you can always quickly rederive the formula. I don't know what to tell you to do about missing minus signs, but okay. I'm the poster boy, as are most people, for doing that. Just be careful and double check. Okay, so this dot product equal to 0 is easy to calculate. Just this times this, this times this, this times this. So we get 1/3 x minus 2, 2/3 y minus 3, minus the quantity z minus 2/3, and that has to equal 0. If it does, then the point x, y, z is on the plane. If not, it isn't. We rearrange this easily enough to get an equation, except I screwed up the sign here. That should be a plus 2y over 9, and then it should be minus 2/3 here, and we have minus 2/3 here, which gives us minus 4/3, and a plus 2/3, which gives us a plus 2/3, so we still got plus 2/3. What's the matter with that? No, I think it should be minus 2/3. Which makes it plus when we solve for z. See if that's right. If I've solved this correctly for z, and I don't want to take time while you're watching to verify that, we do get the equation then z equals x over 3 plus 2y over 9, and I'm still seeing a plus 2/3 because I've got two negative 2/3 and a plus 2/3, negative 2/3 here, so that it actually should be minus 2/3. which gives us plus 2/3 there. Okay, I think that's probably right, but be careful. So there's the equation of the tangent plane. Now, why is this important? Well, it's very important because the tangent plane gives you an approximation to the values of this function close to the point 2, 3, where x equals 2, y equals 3. Why is that important? Well, you're going to have to do some examples to see it. And one example I mentioned in class is an example of estimating the net uncertainty if the value of x, if the values of x and y are observed to be 2 and 3, but you have an uncertainty of, say, 0.1 in x or 0.2 in y, you can use this idea to estimate that. And that's what we're going to talk about here. So to just talk briefly about that. And in the context of estimating f of 2.03, 2.93. Now you can easily go to your calculator. X over y would be this over this, and that's what the value of the function would be. Okay, and we actually calculated that and saw that it was 0.6962. But let's talk a little bit just about how the variation, because 2.04, 2.93 is close to 2.3, we should be able to base an estimate based on linearity of what this ought to be, just based on these partial derivatives and if we desire the tangent plane. So we'll come back to that in the next video.